I have earlier explained the meaning of the redox titration. It's the reducing and oxidizing reactants during that titration. So now we are just going to go through the procedure first before we answer the questions. So in this case, we are going to start with, we go direct to the procedure. You are provided with solution Q1, acidified potassium permanganate 7, which is written chemically KMnO4 in brackets. Solution Q2, made by dissolving 3.7 grams of ferrous sulfate salt in 200 cubic centimeters of distilled water, and the solution is diluted to 250 cubic centimeters. You are required to determine the concentration of solution of Q1, KMnO4, in brackets, in moles per liter. So in this case, we went to an extent by filling the titration table, and we already maintained the 1 decimal point as it's supposed to be. So in the first column, we found 24.0. In the second column, we found 24, we got 24.2, and in the third column, we found 24.0. So now we are just going directly to the questions here. We have been told to determine what? We were told to determine the average volume of solution Q1 used. So in this case, in as far as our table here is concerned, we are going to take the two loss values, the two accurate values. We are going to eliminate this because of this 0.2. Because in the second values, they were not very much accurate because they are not very close to each other. So we are going to say the average volume of solution Q1 is equals to first titer plus second titer, first titer plus third, first titer plus third, then we close the bracket over 2, which is in cubic centimeters. So we are going to take this 24.0 plus 24.0, we divide by 2. All these are in cubic centimeters. You are supposed also to arrange your work very well, and your work is supposed to be very neat. So in this case, we are going to get, for us to minimize the space, we are going to get here to be 48.0 divided by 2, which is finally giving us 24.0 cubic centimeters. We have answered that. So we were also supposed to determine the concentration of Q2 in moles per liter. We were told determine the concentration of Q2 in moles per liter. So in this case, that we need to ask ourselves if 3.7 the concentration of this, of Q2, this one, this Q2, we are going to equate it this way. Molarity, it is always equal to X, of which we know 13 point, these ones, 13.88. Molarity, it is always mass in grams per liter, divided by the RFM. So it's going to give us, we must also calculate the RFM of the iron salt. So we just write here RFM of iron 2, sulfate. This is the chemical formula of iron 2 sulfate. So now we are going to get to ask ourselves, what is the relative atomic mass of iron? So we are going to calculate the relative atomic mass of iron. It is always 56 times 1, which is always 56. Then sulfur, it is always 32 times 1. In this compound, it is just one atom of sulfur, which is going to give us 32. And then oxygens are 4. So we take relative atomic mass of oxygen, it is 16 times 4, which is giving us 16 times 4, it is always 64. Then we add everything of all this, which is giving us 152. So the relative formula mass of iron sulfate is 154 grams. The relative atomic mass of iron 2, it is 154. So we are going to say, therefore, our concentration is the same as molarity, which is going to give us 13.88 divided by this relative formula mass 154, which is going to give us, we go back to our calculator, 13.88 divided by 154. So it's giving us 0.009 M. We have answered that one. So let's go back to, let's answer the next question. We were told to determine the number of moles of Q2 loose. That is question 1, 2, 3. Determine the number of moles of solution Q the number of moles. Number of moles of, determine the number of moles of Q1 used, of Q1 used, of Q1 used. So the ionic equation is like this. Written like this, plus remember this arrow, now I'm writing the product on this side because we have our space is very much minimal on the other side. So we are going to have these ones, our products are as follows. Mn2 plus 5 iron plus this is an aqueous, this is an aqueous, this is an aqueous, this is also, this is a gas, an aqueous also, this one is an aqueous in ionic form, it's not a gas. And also this one is an aqueous. So, we are going to approach it this way. The mole ratio in this case, it is 1 to 5. I want you to follow it very clearly because our interest products here are manganese, potassium permanganate in ionic form, it's written like that, and then iron 2, it's written like this. So now, we are just going to make sure that everything balances by writing the valencies to make sure that everything balances. That's how it's supposed to be. So now, manganese, potassium permanganate in ionic form is written like that. Aqueous plus hydrogen, which are 8. Aqueous plus iron, aqueous. These are 5. So I'm just going to illustrate this so that you don't get confused. So in this case, our equation is just like that, and our complete equation is this way. I've just extended this so that you can be able to understand what I'm trying to put across. So our mole ratio here, our mole ratio is 1:5. These are our products of interest. So we have found the moles here to be, remember the number of moles of iron 2 we already know. The number of moles of iron 2 we already know. They are here. So we are going to write like this. The number of moles of iron 2 we already know. They are 0.00275 moles. So, and we have been told to calculate the number of moles of Q1. Remember, this is Q2. This is Q2 and this is Q1. So, the number of moles, we are supposed to calculate this one as the number of moles to get the number of moles of potassium permanganate. So now, because of the mole ratio, we are going to divide it by 5. Because if this one can be able to give us, what about 1? So it is a fifth of that. So 1 over 5 times 0.00275 moles. So if we do your mathematics properly, we are going to get something like this. 1 times 0.00275 So these are the number of moles that were in 24 cubic centimeters of that solution. Here, these are the number of moles. We have answered that. So now we are going to determine now. We are supposed now to determine the concentration of Q1 mixed. That is number 5. Determine the concentration of solution Q1 used. So now we are going to approach it this way. We are going to ask ourselves some questions. For example, I've told you these are the number of moles that were present here. So we are going just to equate it this way. If 24.0 cubic centimeters have this number of moles, 0.00045 moles, what about 1,000 cubic centimeters? We are going to take 1,000 cubic centimeters times 0.004. 0.00. I think there are supposed to be 3 zeros here. If I'm not very 0.00455 moles over 24 over 24 cubic centimeters. So we are going to go back to our calculator and get this concentration of potassium permanganate. We are going to multiply 1,000 times 0.000455 divided by 24. So we got it to be 0.0189 molar. I hope we have answered that one. Last but not least, thank you for listening to me, and we shall be meeting you in the next virtual practical class. Remember to subscribe, also to like, and also to give some comments down there. Also sometimes even correct us. We shall receive your correction with a lot of positively. Otherwise, thank you in advance. We shall be meeting you in the next virtual practical